Alright, so here we are with our natural log. So basically the only difference between natural log and your regular log of just log is kind of this different abbreviation, but also its base. So log log has a base of 10 always, and natural log actually has a log of e. But you'll notice that I crossed this out, and that's because natural log is actually abbreviated ln. Traditionally what happens is people will write it with like a cursive L, so that you understand that that's an L and not an I. And so just be very careful when you're doing this that we are talking about ln. I do have quite a few people that don't think of this as an L and an N, but it is natural. So there's where the L comes from, log. And so then once we get back into person and you haven't heard me say that it's ln, you'll all of a sudden say things like, oh, well, we're going to take the in of both of these or something. So either way, it is technically an L, but of course if you write it this way, I wouldn't necessarily know if you thought it was IN or LN. So I guess that is up to you to watch this video. Alright, so this is the inverse function to our e to the x. Oops. And so the idea is that if you take the natural log of e to the x, you're going to get x. Or if you take e to the natural log of x, they're going to cancel and get x. So that's what your inverse idea is about. So again, your logarithm in this case is your opposite operation, in this case to a function with base e. And we did talk about e in our previous lesson. So taking a look at our exponent format, again, you see e to the x like I've shown earlier in the examples. And so in order to rewrite this, we're going to rewrite it as log, technically, base e of a, if we rewrite it, and that's going to equal x. And for some reason I didn't use the colors, which is going to make it a lot easier. So log base e of a equals x. Now, of course, what we don't write is log base e. Instead of writing log base e, we just write natural log. And it's assumed to be base e. So, if we want to convert from exponential to logarithmic format, something that you'll be asked to do, we have done this quite a bit, but now, of course, our base is e. And so now they're going to say, okay, well, how do you write this? Well, it's natural log. That takes care of this e. And then it's of 5. That's the answer. And then to the power of is your equal. So same format of these kind of arrow ideas. All right. So remember that inverse operations reflect on y equals x line. Oops, whoa. So if we draw our y equals x line, and we graph e to the x, and we graph natural log of x, they are going to be mirrored on this line. So if we go through and evaluate some of these values, for instance, e to the negative 3 versus natural log of negative 3. Okay, so just realized that my headphones weren't plugged in, so maybe now you can hear me better. Either way. So what we're going to do is evaluate the values here. And so e to the negative 3 is actually 0.05. Then we have negative 2 is actually 0.2. And of course you can be plugging this in on your home screen, or you could put this into y equals on your graphing calculator and go to the table. Lots of ways to evaluate this. The next one is 0.4. And then we have 1, 2.7, 7.4, and 20. Alright, in the other one, natural log actually can't be any negatives, and so you're going to get some sort of like domain error message or something, and so it's actually all errors until actually not 0, because that's where the asymptote is. And so then actually at 1 we're at 0, and at 2 we're at 0.7, and at 3 we're at 1.1. So if we graph each of these, again, they're going to hopefully reflect across this y equals x axis, otherwise they're not inverses. So let's see, I'm going to start with 0, 1 in this first column here, and then go to 1, 2.7, and 2, 7.4. Because then we can kind of see that it's going to be going down here. So -1 is about a little less than half, and then it kind of just goes towards the axis, which of course is going to be your asymptote. So we have an asymptote here for that equation, the exponential one, and then for the other equation, again, nothing's happening until we get to 1, and so there's 1, 0, and that's the reflection of this point over here. So across the axis, and then 2.7, and then 3, 1.1. And then it is going to go up at that same rate as the other one, and then again, because of that error, this is going down towards the axis, but it's going to be an asymptote. So again, hopefully you can see that that's kind of inverse or reflected. All right. So the last piece there is, how do you know that f of x and g of x? So how do you know that this exponential graph versus this logarithmic graph are inverses? And it's because they reflect on the y equals x line. So visually, that's what we can see. All right. So we do have an assignment, which will go through kind of some examples and practices of natural log and how to rewrite them and such. So that is what is asked before we move on to our assignment.